Okay, so today we're going to talk about the details behind reasoning and logic and sort of look at the foundations of the rules that make up what this type of thinking and what this process is. So first we're going to start with two definitions. A sentence that is either true or false but not both is defined as a statement. A statement with opposite truth value of the given statement, negation of a true statement is a false statement. If P is true, then not P is false. We call this a negation. Okay. So in logic, we make a sentence. We say something, and logically, then either that sentence is either true or false. It can't ever be both. And sometimes it's necessary to look at the opposite of that particular sentence, and so we call that a negation. Okay, so we're going to look at a couple of examples of what this looks like in a very simple sense. So negate the following: 2 plus 3 equals 5. Again, we're not saying whether we agree with, I mean, yes, we understand 2 plus 3 is 5. We're saying what is the negation of this statement. So the opposite of 2 plus 3 equals 5 is 2 plus 3 does not equal 5. What is the opposite of a hexagon has 6 sides? That is, a hexagon does not have 6 sides. Okay, a couple more vocab words. A quantifier are words such as all, some, every, there, exists, uses to identify some sort of quantity or an amount of some kind. Then we have a universal quantifier. And applies to the extreme cases of everything or nothing. Then we have what's called an essential quantifier. Sorry, existential. And these apply to some sort of condition. So maybe we're not talking about everything in the set. Maybe we're looking at a combination or a single value that's related to a particular set. Okay, so we're going to go back to this idea of negation, and we're going to tie into it this idea of quantifiers and look at how that impacts the sentence related to it. So in this case, it's not enough simply to throw the word not in there. We actually need to look at the context of the quantifier and think about how we can negate it as well. Okay, so let's start with the sentence, all students like hamburgers. We're saying everybody likes hamburgers. So the opposite of that is not necessarily that none of them like it, it's that just some of them do not like it. So the negation, some students do not like hamburgers. Okay, some people like math. I guess some people like mathematics. So the negation of that, if we happen to think that some do, so the opposite of that some would be that no one does. So no people like math. Okay, let's do this from a little bit more of an abstract sense. the statement, there exists a natural number n such that 3n equals 6. Okay, so there exists suggests that somewhere out there is a singular value. So the opposite of that would be for all natural numbers. Uh, 3n, and then the opposite of 3n equals 6 would be 3n does not equal 6. Now let me take a quick sidestep here from this conversation. We're not using common sense to look at the truth statement of this. We know we can find an n in 3n equals 6. We know we can solve for n. That's not the point. The point is the language and the vocabulary. We're looking at how to negate things. We're not worried about whether or not we believe or know it to be true. We're just looking at how to, think about in elementary school when you looked at writing sentences. We're just looking at how to write sentences. Okay, so please don't get locked up in the logic. Focus more on the vocabulary and how to negate that particular term. Okay, so for the next statement, for all natural numbers n, 3n equals 3n. Now, you and I both know that makes sense, right? But that's not the point. We're looking at how do I negate the phrase for all, and how do I negate the 3n equals 3n? Okay, so going back to sort of in level, the for all means everything. So the opposite of everything would be something, and the opposite of something would be nothing. That makes sense. So there's sort of like this ladder system here of how we're trying to opposite these statements. So the opposite of for all would mean that there's something out there. So there exists a natural number let me try to write that a little bit nicer. Natural number n such that, okay, and then I want the negation of 3n equals 3n, so 3n does not equal 3n. Okay, so we're now going to go into symbolic logic and sort of look at some rules and vocabulary associated with how to manipulate symbols in the same idea of true statement. So we did a verbal expression, we did sentences, now we're going to look at symbolically. Okay, so let's first start off with, a basic truth table is simply an organization on how to identify whether something's true or false. So let's start with the statement, some statement P, and P itself is either true or it's false, right? Let's go back to the original definition of a statement. Then we're going to look at the negation of P. So not P. Well, if P starts off as true, then the opposite of that would be false, and the opposite of false would then be true. Okay. Now, a little side note, if you look up other ways to write not or negate, you've got this little tilde symbol that you'll see, a little backwards L, sorry, upside down L, are all different symbols to indicate that we're negating something. Okay, a conjunction. A conjunction is when we link together two statements, so we form a compound statement from two givens. So in this case, we have a P and we have a Q. Okay, and I'm going to make a list of all the possible combinations of P and Q there are. So both P and Q could be true, P could be true, Q could be false, P could be false, and Q could be true, and P could be false, and Q could be false. Okay. All right. A conjunction is this idea of and we use sort of a caret-looking symbol, one that you might view as sort of an exponent, to represent a conjunction. And a conjunction is true only if both statements are true. So P and Q is true if P is true and Q is true. Okay, so the conjunction then has its own set of truth values. So if both are true, then it's true. If anything is false, then the conjunction itself has to be false. Okay, a disjunction is again another linkage between two statements. Let me go back to our original P and Q, and then we'll talk about what a disjunction is. So let me write down the 4 different possibilities. True, false, false, true. Okay, so the symbol for a disjunction is an upside down caret symbol, or it kind of looks like a V. Okay, we'll go with a V, but it's the opposite of a conjunction. And this represents the word or, so P or Q. And so a disjunction is false if both statements are false and true in other cases. Okay, so a disjunction is, so the or is false if P is false and Q is false. Okay, so otherwise it is true. So if P and Q are both true, there's a true there. One of them's true, so the or statement is true. Sorry, I got that backwards. So since there's one truth, and that's true, and then if both are false, then the or statement happens to be false. Okay, so we're going to look at a conditional and a biconditional statement. Let me start by first defining in any given statement. So we have this P, we have these two statements, this P and this Q. Okay, so the P statement, or the initial statement, we refer to as the if statement. So if this condition happens, and the conclusion is typically our Q, we get the then. Okay. Now, when we look at the truth table for this, go back to our 4 statements here. So we got true, true, false, false, true, false, false, true. Okay, so we define the truth value for a conditional statement that it's only false if this makes sense, the if statement is true and the then is false. Okay, so the only situation that the conditional truth value is ever false is if we see a P of T and a Q of F. That's one way to think of it. Okay, so that means if they're both T, then it's true. Here's the one scenario we're talking about. So if the first statement is true and the second one is false, that we define to be a false conditional. I did it again. Okay, and in this case, if the initial statement is false and the second statement is true, we still define that to be a true statement. And if they're both false, we define that to be true. Okay, so this is a definition concern. You just have to memorize that if you ever see the first is true and the second is false, that you end up with a false.